2.2 polynomial functions of higher degree. So higher degree means bigger than 2. Okay? But the same rules apply for quadratic as for higher degree as well. So, continuous function. A continuous function has no breaks, holes, or gaps. So, this is a continuous function. See how nice and pretty it is? And is this continuous down here?
Yes.
Yes? Okay. They only have smooth, rounded turns. So is this continuous?
No.
No. I had to pick up my pencil to draw it, yes? Now, this next one says only have smooth, rounded turns. Is an absolute value function continuous?
No.
No. Because it has a sharp turn. So a polynomial function has smooth, round turns. Nice smooth. That's why I always yell at you when your parabolas look like mountains. Am I good? Hopefully you're not writing every single thing on every slide, guys. It's too much.
Touching the garage.
Good? Okay. On the right, is that even or odd? Look at just the graph, not the words. Started up and ended up. That's an even or an odd function? Even. On the left, I said that wrong. On the left, it's even. On the right, it starts down and ends up. So it is what? Odd. You know that, right? Now, the larger n, the variable, exponent, the flatter the graph. This looks right here like, ooh, that's curvy. This looks like it's flat, right? But it's really not. It still only touches the vertex at one place. It's just really, really close.
Mr. Day today, I will dismiss you from the intercom.
Okay, questions on this?
No.
Okay. I'll review. We've done it before. Yes? Okay, leading coefficient test. Leading coefficient test only determines the n behavior. Does not tell you anything else about this graph. Got it? Okay, so is this graph odd or even?
Odd.
Odd. Why do we know it's odd?
Because it starts from the bottom.
Starts from the bottom, ends from the top, or just it starts and ends in the opposite direction, yes?
Yes.
Is A positive or negative in this one? It ends up, so A is positive. So A is greater than 1. Actually, that should be 0, shouldn't it? Okay. So, in this one, is A positive or negative? Negative. So A is less than 0 because it ends down. Get it, guys? Right to left or left to right, it ends down. So that's the end behavior. Now, they write it as f of x approaches. F of x is the same as y, yes? As x approaches infinity. Like when we did our parent function notes, we did those, right? But I'm okay with you telling me this. I'm good with that. Are those the ends? Is that what the ends look like? And these ends look like this. Okay? So when you look in the back of the book or on CalcChat, it's going to have an answer like that. But no, this is y and this is x. So the y's are going up, then the y's are going down. Questions? Okay, these are what functions? Odd or even? Even, because they start and stop in the same place, correct? Okay, so is A positive or negative here? On this one. It's positive. How do you know it's positive?
Because it ends up.
It ends up. And since it's even, it had to start up, right?
Yes.
Okay, so A is what here?
Negative.
Negative. Again, the leading coefficient test only tells you what happens on the what? Ends. Nothing in the middle. This could go. Okay? Clear on that? Okay, so describe the right and left hand behavior of these graphs. So, first of all, decide if it's odd or even. Then decide if it's positive or negative. So, A, odd or even? Odd. Positive or negative? Negative. So it ends down, so it had to start what? Up. It's about the only time you'll ever see me do the right hand stuff before I do the left hand stuff. Okay? Odd or even on B?
Even.
Even. Positive or negative?
Positive.
Positive. And you're all looking right here, right? It's the only place you're looking, isn't it?
Yes.
Okay. So it's going to end up or down? Up. So that means it has to start up because it's even, right? Okay. Do the last one on your own. Should have odd, positive, so it ends up, so it starts down. Are we good?
Yes.
Okay. Zeros of a polynomial function. For a polynomial function f of degree n, f of x equals x to the n. A function has at most, oh, and I touched it. At most n real zeros. Okay. Now, once we do, I don't like this because it actually has, the word that they're using is what? Real. Okay, I'm going to tell you right now, x to the fifth has at most 5 real solutions, but it has 5 solutions. What did I leave out? Real. Because some of them could be imaginary. Yes? Okay, so know that it has at most 5 real solutions, but it has 5 solutions. Just no guarantee that they're all real. You could have 4 imaginary and only 1 real. Because a real is where it crosses the x-axis, yes? So could this function, since it's odd, look like this? Could it like that?
Yeah.
And how many times does that cross the x-axis?
4.
Once. So the rest of them would happen at imaginary solutions. Okay? Okay. The graph of f has at most n minus 1 turning points. So I added my x to the fifth again. And I don't know if any of you noticed I was counting to make sure I did 5. 1, 2, 3, 4, 5. So it turned once, twice, 3 times, 4 times. Do you see that? That makes sense when I'm talking about turning points?
Yeah.
So these things would also be called what?
Vertexes?
Nope. minimums and maximums, relative, and we call them relative because there's more than one, right? So they would also be relative mins and maxes. Turning points happen. I think if I hit this over, can I get rid of my beautiful picture? Is it going to affect anybody?
No.
Okay.
I'm going to be heartbroken.
Yep. The next one says, also called relative minimum or relative maximums, are points at which the graph changes from increasing to decreasing. So this graph was increasing, decreasing, increasing, decreasing, increasing. See that?
Yes.
Remember, increasing and decreasing is in a direction. Positive and negative are above and below the x-axis, correct? Okay. Finding zeros of a polynomial is one of the most important problems in algebra. It is one of the problems. Okay, zeros, x-intercepts, solutions, are those all the same things? Yes. We find them by setting it equal to 0 and solving. Polynomials, we factor. Correct? So, this is something that is never going to stop. You are going to do it in every math class you ever take. You will be finding zeros. It's just what the equations look like that will change. So, how do I find an x-intercept, a solution, or a 0? I set it equal to what? 0. So evident, the same thing as saying change the y to 0, correct? Let me know when you guys are ready.
Ready?
And Ainsley's still writing.
You can.
Okay. I know there's something there. There it is. Okay, repeat zeros. Now, don't write this down until it means something to you. So don't start writing until it means something. It says a factor x minus a to the k, where k is greater than 1. Okay, so k is the exponent on that quantity. Yes? Is called a repeated zero of multiplicity k. What's multiplicity mean?
How many times?
How many times it happens. Okay, it says it's repeated. Same thing, right? So if k is odd, the graph crosses the x-axis at x equals a. If k is even, the graph touches the axis but does not cross the axis. So again, let me repeat that. If k is odd, it crosses the x-axis. Okay? At x equals a, because you set this equal to what? 0? Okay? But if k is even, the graph what? Touches. Remember me bouncing off the door last year? Did I do my bouncing off the door thing?
What are you doing?
Oh, I'll have to show you then since you don't know. Okay, so if I have x minus 3 to the 7th, does it cross or bounce? Cross. Because k is odd. Yes? And the multiplicity, x equals 3, how many times? 7. I just put a little times 7. The book says molt 7. I don't want to write molt every time. Your problems will say state the multiplicity. If the multiplicity is 1, don't state it. Got me? Okay. So I have x minus 4 to the 4th. Does it cross or bounce? It bounces. Okay, so what's that mean is, let's take my door stuff out, since we don't know what I'm talking about. Okay, so k is the number of times I touched the door, okay? So I touched it once, can I go through the door?
Yes.
Yes? I touched it again to close it, can I go through the door now?
No.
Because I, what?
Bounce.
I bounce. So that would be a multiplicity of 2. I open a third time, can I go through the door?
Yes.
Yes? But I touched a fourth, so I shut the door.
Bounce.
I'm going to bounce because the door is shut. Does that all make sense? Okay, that is important because when we talk about whether things, remember the change, like they had to have n minus 1 change. Okay, those count because I go down and I bounce it and I go up. Am I good? Okay, real zeros. This is just something, guys, I want to reiterate to you. I've said it over and over and over again. I'm going to say it again. To find a zero, you set an equation equal to 0, yes? And then I factor. So if I ask you for a 0, you write your answer as x equals an answer. Okay? If I ask you for a solution, you still give me x equals. If I ask you for a factor, you give me a what?
X minus A in parentheses.
Or you give me a factor. Yes? Okay. Sometimes the factor may be x squared minus 7x plus 2 because you factored out something else, right? But you give me a factor. This is a linear factor right here. But if I ask you for an x-intercept, you always write it as a what?
Point.
A point. Because an x-intercept is a point on a graph. So when I grade a test and I ask for an x-intercept and you give me x equals 6, are you going to miss a half a point? Yes. If I ask for a 0 and you say 7, 0, are you going to lose a point? Yes. Got it? When I ask for a factor and you say x equals 28, are you going to lose a point? Yes. Those are called vocabulary checks. Got it? Okay, I'm assuming there's something else. Let me click. Oh, okay. Says find all the zeros of negative x squared plus 2x. Well, we set it equal to what? 0. And what? What am I supposed to do? Factor. How?
Factor out negative 2x squared.
So factor out negative 2x squared. Because any kind of polynomial, I should always factor out what they have in common first, correct? Mm-hmm. So you have x squared minus 1. Mm-hmm. Okay. Are you done factoring?
No.
Why?
Because you still have the 2x squared.
2x squared is factored.
Oh.
What about x squared minus 1? Is that factored?
No.
No? Why not?
X plus 1.
X plus 1 minus 1 because it is a difference of squares, right? Now, you set every single one of these equal to what?
0.
0. So my answers are least to greatest.
Negative 1 half, and then
We're getting 1/2.
I have a brain part. The 2x.
Okay, but I would divide 0 by negative 2 and get 0, and 0 equals x squared.
Yeah, I have a brain part.
So it is negative 1, 0, and 1. What is the multiplicity of these zeros? 1 and negative 1 is 1, right?
Yes.
What about the 0? Well, you take the square root of 0, but when I take the square root, it's plus or minus, correct?
Yes.
Is there a plus and minus 0?
No.
No. But so that does mean my multiplicity is what? 2? So if I then ask you to graph this, Well, I have to put at -1, 0, and 1, I have to put a 0, right? So put a 0. What is this graph? Is it odd or even?
Even.
Even. It's an even negative, so what's my end behavior? What are my arrows going to look like?
It's gonna bounce.
They're both down. Okay? So if they're both down, correct? This graph must have to go through here, come up somewhere, and come back down. Is it going to go through 0?
Yes.
The multiplicity is 2.
No.
Nope, it's going to what?
It's gonna
Bounce off. And then come up and go back
through 1.
through 1. Now, we do not know how tall this went, do we? That is for calculus. Calculus will find the first derivative and we'll know where those extrema are. Okay? But we do need to have the shape. So let's see. This is going to go away because I can't keep them both. Does ours kind of look like that?
Yeah. Yes.
Okay. Okay, use the leading coefficient test, find all the zeros, determine the multiplicity of each zero, and we're going to sketch the graph. So basically what we just did. I'm not going to write in black. Okay, leading coefficient test, odd or even?
Odd.
Odd or even?
Oh, even.
Even, positive or negative?
Negative.
So what are my ends going to look like?
Down.
Down. So down, down. Okay? Find all the zeros. How do I find all the zeros?
Set it equal to 0 and factor.
Set it equal to 0 and factor. So hopefully you're factoring out a negative, yes? Get 2 and 8.
Yes.
Okay. Check. Check. Determine the multiplicity. Remember, if it's only 1, I don't care. Is it any greater than 1? What's the multiplicity of the 2 and the 8? 1. Because it's the exponent on the quantities, guys. What are the exponents on both of those quantities? 1. If there's nothing there, what is the exponent? 1. Because you're looking at me like I'm crazy. Okay. So did that. Now I need to do what? Graph it. And it is just a sketch. Don't be going to get graph paper. That would make your life absolutely horrible. So we're at 2 and 8. And it's even, right? Well, it's just a parabola, isn't it?
Yeah.
So where's the y-intercept? Isn't it negative 16? Because it'd be 0, 0, negative 16. So we're not going to cross right here. If we do cross, we'd have to put a line and say 16, right? Negative 16. Or you can just avoid that. Now, I didn't find the vertex, but could I have?
Yes.
It would have been right here, wouldn't it? So that is 1, 2, 3, 4, 5, isn't it? How do I know it's at 5? It has to be right in the middle, right? So what would that be? Negative 25 plus 50 minus 16. So this would be 41. So just 9. So that wasn't hard. I would do some of those things just so you remember how to do them. Okay? Could you have also done negative b over 2a? Yes. But once you have the zeros, it's right in between. The only time I wouldn't do the right in between if it was like 2.5. Questions? Concerns? Objections? No.
I object.
Okay. Same thing. Negative 4x cubed plus 4x squared minus 15x. Odd or even? Odd, positive or negative?
Negative.
So it's going to end down, but start what? Up. Find the zeros. How do I find zeros?
So that equals 0 factor.
Set it equal to 0 and factor. Oops, I forgot my x. Negative x, right?
Eighth graders, your turn to smile. Please report to the auditorium. All eighth graders, please go in the side of the media center. Walk by the media center and then into the auditorium.
Okay, did you guys get negative x, 4x minus 10, and x plus 1? Not 1, that's...
Not there yet.
Oh. Well, that's what you get. Okay. So, my x-intercepts...
This is like,
What?
wouldn't it be, yeah, wouldn't it
10
be
and
negative 6?
It'd
No.
be positive 6.
Oh, yes, it would be 6. Sorry. I knew I had to get 4. My brain was on 4. That's easy. I can fix that. Okay, so I need to erase that and that. So 2x and 2x and 5 and 3. Better? Okay. Oops, I forgot my x. So I get negative 5 halves, positive 3 halves, and oops, 0 comes before positive 3 halves, doesn't it? Do you guys remember why I always try to put mine least to greatest?
Because then it's in order.
Then it's in order when I'm ready to put them right on the x-axis, right?
Yes.
Okay. Oh, I didn't do turning points on the last one. How many turning points am I going to have?
3,
No. Minus 1.
2.
2. And multiplicity of all these is? So there's a 1, a 1, and a 1, right? So now we got to graph it. So negative 5 halves is negative 2.5, right? So 1, 2, 3, and 1 and 1.5. 1, 2. And we know it has to end down, right? So it has to start what? Up. And all of them have an odd multiplicity, so I just go through. And there I go. How beautiful is that?
If you have to start up, why would you put the arrow at the top of the start?
What?
Like,
Because it goes forever.
okay.
But I typically, like when I draw mine, I do that.
Okay.
But it goes forever in both directions, technically. But you'll usually see me start and then just put my arrow at the bottom. Other questions? I think I have one more. Do we need to do one more, guys? I've got other examples. Do we need another one? No? Are we good? Okay. Find a polynomial function that has the given zeros. So these are zeros. So I'm going to go backwards. Zeros came from what?
Function,
You went too many steps backwards.
the factor.
The factors. So I moved these to the right. Now I have to move them back to the what? Left. So x equals 0 would just be x, would it not? And what would be the factor for the 8? It's a positive 8, so it was a what?
Negative.
Negative 8. So now that I have factors, I have to do what? Keep going backwards to get a polynomial. I have to FOIL, I have to multiply. So hopefully we all get x squared minus 8x.
Yep.
Okay, what are my factors on my other one? I have zeros are at 0, -4, -5. X.
And then x plus 4, x plus 5.
And then I have to FOIL, right? So x squared plus 9x plus 20
Yeah.
times x. Oops, I didn't change to green. I was trying to do my steps and colors. So x cubed plus 9x squared plus 20x. Not that bad, is it?
Horrible.
Horrible. Now, find a polynomial with degree n that has the given zeros. So I have 1 0, but I want what degree? Third. So what factor did x equals 9 come from?
X minus 9.
X minus 9. Now, in order to get a third degree, I'm going to have to put a what on this quantity?
A 3x1.
So that means I have to do x minus 9 times x minus 9 times what? X minus 9. I'll give you the first one. It's x squared minus 18x plus 81. Now you get to FOIL the next one. Can't write what my brain is thinking. Did you get the same thing I did? Are you getting it? Matthew, you're not even doing it.
I am.
No, you're not. Did you get the same thing I did? Okay. I did not FOIL. I used Pascal's triangle, which we will work on this year. Okay? So, I did not FOIL, but I'm glad I got the same thing you did. Because it's been a long time since I used it, but it does work out better. So this one I had to multiply the same factor out 3 times. On the next one, do I have to? I want a degree of what? 4, but I have how many zeros? 4. So am I going to have to add extras? No. All my multiplicities are going to be what? 1? Okay, so it'd be x what? Plus 1? Plus 4?
And then plus 1, and then minus 3, and minus 6.
And then we would FOIL this out and FOIL this out and then do them together, right?
Yeah.
Now, what if I change this 4 to an 8?
You have to do it.
I'd have to square not everything. Would I? Oh, wait, I didn't want to do that. Well, okay. If I changed it to an 8, could I square everything? Yes. Could I do 4, 2, 1, and 1? Yeah. As long as it adds up to what?
8.
8. Does that make sense? Do you guys want to multiply this out? No? But you know you have to, right? Can you guys multiply this really quick?
Yeah.
So x squared plus 5x plus 4. Okay, so you got this really quick, right? And x squared minus 9x plus 18. It's the next part you don't want to do, right? But you... Okay, am I good to go on? Just don't stop here, okay? We can come back if you want. Okay, this is my last slide. A polynomial function can change signs only at zeros. Yes? When I say change signs, everything up here is what? Positive?
Yeah.
And everything down here is what? Negative. Because it's the y-axis, isn't it? Okay? Between 2 consecutive zeros, a graph must be entirely positive or entirely what? Negative. It obviously can't cross if there isn't an open door, and a 0 is an open door. When all zeros of a polynomial function are put in order, they divide the x-axis into intervals. So one interval is here. One interval is here. One interval is what? There. One is here. And one is here. I had 4 zeros, so how many intervals did that make?
3.
5.
Do not see the green, the red, the orange, the yellow, the blue.
No.
Okay, it's like cutting a piece of string. If I cut a string 4 times, I have 5 pieces. Yes? If I cut a string 3 times, I have how many pieces?
4.
If I cut a string 100 times, I have
101.
101. Intervals are used for interval testing to determine if the values of the polynomial functions are positive or negative, which we will continue to do and work on. Is this function odd or even?
Odd.
Odd. What's the multiplicity of that? 0. Did I go through it? Well, it's even. That's all we know,
About,
right? I bounced, so it's even. Could it be 16?
yeah.
Yeah, we don't know. What's the multiplicity of this one? Odd. This one? Even. But the whole function itself is an odd function because it ends. Is A positive or negative? It's negative, right? So we can tell a lot from that.